Good morning, everybody. Thank you all for being here, and thank you again, the organization, for inviting me to come here. This is my first time in the Philippines, and as you can see from my pictures, I'm quite enjoying it. I even got invited to sit on the roof of a jeepney. That was a bit too much for me. I'm an old guy, right? So, and I'll tell you a bit about being old anyway. So, this is a talk about programming, basically. So it has a lot of code examples. They're mostly not in Python. There's some in Python, but they're in every language that you can think of that is popular these days. So let's get started, right? So if that one wants to connect. So basically, it's about my journey as a programmer, right? So the thing I thought was, so I've been telling stories for 25 years on stages, and I was thinking, so what can I still add, right? So the industry is fully matured, right? It is evolving, we're all learning fast, and so I thought, so over the years I've become to tell much more personal stories. So then, rather than, okay, this is how dependency injection works, so this is what monads are, I started to tell the stuff that I do every day. So I'm actually going to do two talks today. This one, which be much more about code, and I moved out because I have way too much material. So I moved out all the other stuff that is more about teams and about collaboration into a talk that I still need to prepare for this afternoon. So depending on what you guys give me back, I'm probably going to change the deck anyway, right? So, but this is my journey, right? So, so I can only tell you what I've seen in those years. So there's basically two things that I really, really like to do. One of them is to write code, as you probably all do, otherwise you wouldn't be here, right? I can write code all day, right? It's sort of like when you get into flow, it just flows, right? And you cannot be distracted. And when people come up to you and ask you something, you don't even hear them, right? That specific zone, that is, for me, that's like, it's like a drug, basically. Although drugs are illegal and this isn't, so it's a good substitute for drugs. I can tell you from experience, by the way. By the way, writing code, if you just had a beer, actually helps. It's well, not if you have like 10 beers, then your code gets worse, but after one or maybe two, that really helps. So and the other thing I like to do is traveling, right? So when Matt asked me to come to Manila, I immediately said yes, because I've never been here. So this is a picture I took 2 days ago. This is in Batat, and it's amazing. If you haven't been there, go. This is just such an amazing place. And the nice thing about it is, other than me, it's quiet. You just hear the roosters, and you hear a guy in a sawmill sawing some planks, but that's it, right? And that quiet is, well, it's actually another zone that you can get into, right? So I'm going to be telling you a bit about the analogies between traveling and writing code, because there are a lot of similarities in between them, right? I found on the internet this thing called, you can be a travelist. And being a travelist, basically, according to Wikipedia, means this. It's a really a vague description of what it means to like to travel. It's being a travelist means those who wandered to fully experience a new locale, like coming here, the culture, the people, the approaches to the everyday common tasks we'll endure, to learn, to be inspired, to deepen the soul and enlighten the spirit, and refreshen the mind. That is something to keep in mind. And this is basically what I like about traveling, right? It's investigating new cultures. Like, I was with my guide yesterday, and he told me he lived with his whole family, including his children and his grandchildren and his sons-in-laws, because he had 6 children of his own, in one house, and basically all sharing one bedroom. For me, coming from Europe, it's hard to imagine, right? But it seems to be much more normal here, so I guess it's good, right? So this is what it means to be a travelist. And it's the same with coding. I'll explain that in a second. For me, writing code has been a very long journey. So to be quite honest, looking at you, you all look, well, much younger than I, right? I'm probably the oldest guy in the room, I suppose, really. Is anybody born in the 90s? Who's born in the 90s? Anybody later than the 90s? Wow. So is anybody born in the 80s? 70s? 60s? So I'm twice the age you guys are, right? So for me, programming was really long. It started for me here. This is a Hewlett-Packard HP 25. It's a pocket calculator my dad bought a long, long time ago when I was still living with my parents. We do that too, right? So, and my dad was a mathematician, so he bought this thing so he could program it. And I'm like, what is programming? So I was like 12 years old at that point in time, and there was a manual. It's in Dutch, so you won't be able to read it unless you can read Dutch. But so it basically says, this is a nice quote, right? It said, effortless programming. In 1978, right? Effortless programming. What does that even mean? I still don't know, right? And it had lots of nice gestures about how to write code. And a nice thing, my father being really meticulous, he wrote down in the manual when he bought this little machine. This is the date that he bought it, the 24th of September, 1977. I immediately took it from his hands and started to investigate. Move the, yeah, I will. So I have to move, oh, wow, there's a big difference. I'm not that used to these kinds of microphones, so I'm not used to, for instance, karaoke and stuff, so. I got invited earlier this week, but I can't sing. So anyway, so he got this in 1977. I took it out of his hands almost immediately because I wanted to investigate what I was. So that is when I wrote my first lines of code, right? So somewhere around 1977, 1978. And it's been a long, long journey. So for me, just like being a travelist, I could say I'm a codist, right? Those who code to fully experience a new locale. In my case, it's an LNL, right? But the culture, the people, the approaches to the everyday common task will endure. So basically, stories probably. To learn, to be inspired, to deepen the soul, enlighten the spirit, and refreshen the mind. So that is basically what it means for me to be a programmer. And the one thing that programming is all about, it is not typing on your keyboard, right? It's not reading thick books about solid principles or whatever it is. It's about continuous learning. It's about always learning. And it starts here, right? This is the great programmer Aristotle. You can see he's a programmer, he has a beard. And he said, well, it's basically for the things we have to learn, before we can do them, we learn by doing them. And this is pretty much what it's about. There's been a lot of discussion in the communities about, do you actually need a bachelor or master's degree to write code? And I have no specific opinion about it, but anyway, but it is about always learning. And if you look at different ideas about how to learn, this one isn't interesting, right? So this is Japanese, it actually comes from martial arts. There's 3 levels of learning. It says, well, basically you start at the shoe level, where you learn from a master. This is pretty much the Karate Kid movie, right? Where he has to paint the fence, and then wash the cars, and wax on, wax off. That is typically this stage, right? And then you get to the Ha, where you detach from what the master's learning you. You learn to use the stuff that you've learned into the problems you meet every day. And in the end, when you get even better, when it's all automated, and when you come into problems that you cannot solve by the stuff that you learned, you need to start combining it with other stuff. And that is where the interesting stuff happens, right? This is the transcend phase. And if you look into why this talk is called the Zen of Programming, you need to talk about what is Zen actually. So Zen is a state of call attentiveness, exactly the same as what I had in Batat, right? In which one's actions are guided by intuition. And it's this thing that by intuition, right? And if I look back in the 44, 45 years of coding that I had, it's mostly guided by intuition. It's looking at a piece of code and just, you know, even my face starts to twitch, right? If I look into a code, I'm like, and you look at it and you can improve it, right? And you know you can improve it. And it gets better. And usually it gets smaller once you do that. And that's the interesting part about the learning thing. So for me, it's always about this intuition thing. It's basically when you become one with the code, lost in the rhythm of the tasks at hand. Now, isn't that beautiful? This is what we do, right? Every day. And if you do that, you have to figure out how learning actually works. Now, I took an interesting metaphor from a brilliant book by a guy called Gerald Weinberg, and the book is called Becoming a Technical Leader. It's a really old book, but it has a fascinating story in there. And the story is about learning. Now, Gerald Weinberg, who wrote about 70 books, by the way, he was interested in how he would learn. So what he did is, he tried to learn to play on a pinball machine. So in his local cafe, there was a pinball machine, and he started to play it. And then he figured out, well, wait, if I learn, it's probably going to be linear, right? The more I practice, the better I get. This is an assumption we all make, right? So the more you practice, the better you get. That is not automatically true. Because what he realized when he started jotting down the scores is that it actually wasn't like that. It was like this, right? There was a time when he was progressing slowly, so this is just brute force practicing, right? And then at some point in time, all of a sudden, his scores start to rise, and then it went up again like this. And it got even worse, because he made a graph of all the scores, and then he saw something different. What he saw is basically this. It actually has gaps. And the gaps is where the interesting takes place. This is where you actually learn. And you might think, how can it be possible that the scores go down if you're actually learning? And I'll explain to you why that is. This is because when you are progressing slowly and you come up with an idea at some point in time, you have an epiphany. Something you didn't try before. One of the examples he gives is that he was playing on a pinball machine that had multi-ball. Have you ever tried that? I used to play pinball quite a lot. Multi-ball is tough, right? It means there's 4 or 5 balls into play, and you try to keep them all in play. And usually what happens is, you see, you've tried it, like you're nodding, like, and usually when it happens, all of a sudden, they're all gone. Which means the game stops. And what he figured out, he got this idea. He said, well, what if I just keep my eyes on one of these balls, and just, if the others pass by, I'll just do something, doesn't matter, but I'm going to keep that one ball in the play. Now, at first, when he started doing this, his scores deteriorated because this was something new that he was trying out. But after a while, after trying it out in several versions of this idea, he got all of a sudden much higher scores. By the way, I actually tried this experiment. It works. If you're on a multi-ball pinball machine, this is a good strategy. It actually works. The last time I played pinball, I broke the all-time record on the machine. I didn't know that, but the owner of the machine came tell me. He said, well, you just created the highest scores ever on this machine. And that was because I used this idea. So this is a good idea, right? If you learn anything today, it's how to play multi-ball pinball, right? So it is all about having epiphanies. And with these epiphanies, these ideas that you're going to try out, you need to experiment. This is the largest part of learning, having epiphanies and doing experiments. And that's what it's all about. By the way, it gets worse. Because next to learning stuff, over the years, I figured out that there's much more unlearning to do than there's learning to do. And I found this really nice graph on LinkedIn or Twitter. I don't know where I found it. I also don't know who created it because it was copied around on the internet. But this is a really interesting graph. And this is basically what I went through. And the interesting about this graph is, well, it says basically, well, you start writing super simple code, right? If you program for the first time, your code is super simple, right? Very basic, straightforward code. Basically the code that ChatGPT would write. It actually does, by the way. So, and then you start investigating object-oriented programming, right? So that's, the thing, yeah, we're going to do OOP. That means we're going to do inheritance, and we're going to do polymorphism, and everything is inherited from something else, and we create like 17 layers of superclasses, and in the end, well, you're probably here, right? You add design patterns, and everything needs to be an observer, and whatever you do, and your code gets really, really complicated. If you work for large enterprises, this is usually, if you come into the enterprise and you look into their code bases, it's usually where they are. They're somewhere here. By the way, this is relative, right? Some companies, the complex means here. Some companies, complex means like way up there, right? So if you go into the Netherlands, you go to a government agency, a ministry or something, or a large bank, they're up there all the way, right? They don't know how to move forward anymore. That's, by the way, where the talk in the afternoon is about. But eventually, you start losing track. You're like, why are we doing this? Why are we adding these 19 levels of abstraction to our code bases? Well, because we learn to do it that way, right? This is what we think is in the books, or what we think much more experienced developers are teaching us, right? You've been there, right? So, and eventually, you get to a point where you're like, why do I need all this complexity in my code? And you start trimming it down. And in the end, you get to something where your code is super simple. By the way, again, this is also relative. What is simple to me could be highly complex to you, or what is complex to me could be simple to you, right? So this is very much in the eye of the beholder. So keep that in mind, right? So this is basically what my 44 years of writing code has been. It's been a quest towards writing super simple code. And again, what is simple to me might be very different to you. But as I told you, this is my personal story. So now what? So where are we now? What do we do, right? This is pretty much like in Finding Nemo, where they all escape from the aquarium, from the fish tank, and they get into the sea in plastic bags. And I'm like, okay, now what? Well, this is a good point to introduce myself, I guess, right? So this is me. This is a big picture of me, as you already introduced. So I'm a dad. I have a bunch of children who all go out to university, by the way, by halfway through the year. That means the last one is going to university, the other two are already there. I speak a bit, I write a bit, I travel a lot, luckily. I'm sort of like a serial CTO. So companies hire me when they're in trouble. And I say, come help us solve the trouble. And then I interview all sorts of people, and I'm like, no, your trouble isn't big enough. Hire somebody else. And then I find a company that has really, really big trouble, like they have to pass the Innovators Dilemma, and then it's like, now I'm coming. So I mentor a bit, I'm a software architect, and I'm basically a lifelong programmer. That is what I do. And there's lots of stuff, but not very interesting. By the way, this is one of my email addresses. If you feel the need to ask me questions afterwards, please do, don't hesitate. Also, I'm on LinkedIn. Feel free to connect. It's probably easy to recognize that you're from this audience. That is, besides the face mask, so I don't recognize anybody, but so reach out. I work for this company called iBOOD.com. Oddly enough, and surprising to us, we actually, 2 months ago, we won the Website of the Year award in the Netherlands, which is pretty cool because my team and I were working on this thing for the last year and a half, rebuilding the whole thing into a new platform, and we got this award, and we were really surprised. So it doesn't really help here in Asia to introduce iBOOD because we're not going to be here anyway, and you have much bigger companies doing e-commerce. So a little bit more about myself. This is my name. It's hard to pronounce. Everywhere I go here in the Philippines, people say, wow, you have a really long last name. This is average in the Netherlands, by the way, right? This is not long. The nice thing is, I am actually double object-oriented. I was born this way, right? So I couldn't help it. It gets even worse because I live in Amsterdam in the Java Street. This is not a joke. This is actually taken from my balcony. So it's, and how much of a programmer can you be, right? So, I also have an open source project together with my team. It's really nice. It has a lot of code samples for when you do microservices in TypeScript and Node.js. That's our latest thing, and we work on this really, really hard. And doing open source is, by the way, really interesting. It's a really different concept than writing code for a company. So again, what is this quest for super simple code? Now, it starts here, right? Or basically, it never ends here. This is, by the way, somewhere north here. I don't know exactly where it is, San Jose or something, some sun city here. Really nice. The thing is, you're never there, right? Your journey is never complete as a programmer. Even after 44 years, I'm still learning every day, right? I'm learning from the guys in my team, guys and girls in my team. I see something new almost every day in what I do. That's not only in programming, by the way, but that's life in general. It's you learn something new every day, and you take it into account to the rest. This is what the epiphanies and the experiments are about, right? So I'm going to show you a whole bunch of the epiphanies that I had over the, let's say, last 40 years. Basically, the first one starts here. This is in Jordan. It's in Wadi Rum, really beautiful. This is where they shot Star Wars, by the way. It reminded me of a story by one of my first mentors, a guy called Wim, Dutch name, typically Dutch name. And Wim used to say, well, imagine you're walking in the desert, and there's a thick fog, and you cannot see farther than like 30 centimeters ahead, right? So what do? And by the way, there might be a brick wall in there somewhere. It might not be there too, so you don't know. And the thing is, this is a metaphor for how to write code. It means be careful where you step, because at some point you will hit a brick wall. And we've all had that, right? We run into a brick wall, especially in places where we didn't expect one. That is pretty hard. That is where you need to come up with some epiphanies. And that is where our great programming friend Donald Rumsfeld, he's not a programmer, right? He has a tie. So, I was actually, my guide yesterday, he said, so you're going to actually wear these trousers to the conference? I said, yeah. It's developers. He said, oh, I expected you to wear a suit and a tie. And I said, well, I don't have one. So, but Rumsfeld says, he talks about, this is, by the way, talk from the Iraq War. He says, well, there's the known knowns. Those are the things we know. And we also know that there are known unknowns. That is the things we know we don't know. But it gets worse. And the worst thing is that there's these things called the unknown unknowns. Now, the unknown unknowns, this is where you hit the brick wall. This is where you need to be creative. This is where you need to invent new stuff, right? And he said, well, these are the ones we don't know. So if you explain this to your manager, and I did actually, I explained it to a meeting with the whole company. I said, well, this is where we are having difficulties with tech. To renew everything, we need to keep the shop open, but renew everything. That means we run into stuff we don't know. So if you ask us to estimate or to when it's done, we cannot do that because we will likely, but not necessarily, run into stuff that we have no idea of right now. And that could happen at any point in time. And this is basically our life as a programmer. That means that every manager who I tell this story, and I do it all the time, they're like, yeah, I get all this. I get all your talk about the unknowns and it's really nice stuff, but when is my project done? And the good answer to that is, I don't know. And it's okay to not know, right? That is okay. As a developer, it's okay to not know everything, but you cannot know everything. So all this stuff about all these timesheets with all these numbers, and I took this from an actual manager from one of the companies I still work for, by the way, and he was measuring the individual productivity of his developers. And I said, stop doing this, because there's no way that you can measure that, because we are in a field that is full of unknowns. And if you are, you cannot estimate productivity, especially not individually. So I said, please stop doing this. He actually did, by the way. So overall, you could say, what about productivity then? What does this word even mean in our industry? Well, the answer is, it means nothing. Unless you are on a repetitive code base that has been built on like the last 40 years, some COBOL stuff that is still left there that you have to maintain, that is pretty much predictable because it's been the same all over. But in general, you could say this, right? Productivity is a hoax because we are not on an assembly line. We don't produce stuff like cars. Like how many cars can roll off an assembly line? That is predictable. That is repetible. Writing code is not repetitive because if it were, then we wouldn't be doing it because we could just copy it from somewhere else or let ChatGPT write it. So I make the hole even deeper, right? And that is that people who think that you write code by typing on a keyboard are wrong. So if your manager thinks that is what we do, and if the manager thinks he needs to measure the time you sit behind your keyboard and type, he's wrong. Because code does not live in the keyboard. It doesn't even live in the computer. It lives in your head, right? Most of the time that you're writing code, it's here. It's not on the keyboard. I write code when I'm in my car. I write code when I'm in the shower. Even at night when I lie awake because of the time difference between Manila and Amsterdam, I can think about code and it relaxes me. But I find new solutions because my mind at that point in time is free to do that. And I got triggered by this by a guy called Ken Beck. Now, Ken Beck is one of the big names in the industry. And at one point in time, at a conference in Aarhus in Denmark, he said, I'm not going to refactor the code just yet. So this was in 2003, as you can see on the slide. I'm not going to refactor the code just yet because the code doesn't know where it wants to go yet. Think about that, right? What does that mean? And when I saw him do this, because I took this picture when I was in the front row, and I had no idea what he meant by that. This is me 20 years ago, right? I was like, what does he mean? And what I think he means is that, well, if you are writing a piece of code and you run into that brick wall, you can try to push harder through the brick wall, but if the brick wall is thick enough, you cannot get through. That means the best way to do it is to let go for a bit. Whenever somebody on my team says, I'm running into this trouble, I cannot figure it out, I need to spend more time on it now, so I'll probably go through in the evening. And I'm lucky to be their people's manager, and I'm saying, nope, don't do it. Just leave it, let it go, start doing something else. Look at it again after the weekend. You'll probably have some fresh ideas. Because this is what happens. The code just pops pops into your head at some point in time, not necessarily when you're trying to put it on the keyboard. So it is this, right? Programming does not fit really well in time box. That's why I said to my team, I don't care when you guys work. I don't even care how much time you guys make on the keyboard or how much time you spend on writing the code. We just need to get this job done. And how much time you do it, I don't care, right? Whether you do it in the afternoon, in the evening, at night, in the morning, in a bar, at the office, sometimes we spend some time in the office or at home, doesn't really matter, right? What matters is how you can get the job done the best. Usually in collaboration, right? So it doesn't really work well from 9 to 5. So what I always suggest to companies is let go of this 9 to 5 thinking when it comes to your developers, because they need the creativity to at some point jump the wall. That is in the desert somewhere, right? So we basically work like this. Managers think that we work from 9 to 5, like from 8 to 12, we take a break and then we work there and then we're done and we start again the next morning. This is not how software developers' minds work. Our minds work like the blue line. At some point in the day, we get this epiphany, right? The little hole that we talked about earlier. And then we need to do something. Then we need to either type it down, write it down, develop it in your head. I actually have code running in the back of my head all the time. I cannot help that. It's just me. Even now, when I'm on stage, there's actually a React component ready to build in the back of my head. I'm not joking, by the way. This is really true. It's actually the spinning control that I need to rebuild. And okay, anyway. So it's true. So the next thing that I learned is that I learned to travel light. Even now, coming here, I'm spending like 11 days, 10 days, I think, here in the Philippines. I only brought a little backpack. I don't travel with suitcases or stuff. I need to put everything in that backpack because it makes me be able, I'm becoming more agile if I travel light, right? So what you need to figure out, and the same goes for programming, right? So you need to maximize the amount of work that you don't do. It's not maximizing the lines of code, because we should not be measured by the lines of code we write, because writing less code is often better than writing more code. We need to bite through the complexity, bite through that wall at some point in time, right? And this is what Neil says, Neil Ford, about complexity. He says, developers are drawn to complexity like moths are to a flame, and often with the same result. We die by complexity, right? I've seen so many companies struggle with the complexity of their code bases, having no way to back out again, right? And this is where it goes wrong. Gregor Ho puts it even better. He says, listen, excessive complexity is nature's punishment for organizations that are unable to make decisions. And this is so much true, right? Whenever you go into an organization and that organization struggles to bite through, to get through that wall conceptually, then they're also not good at managing their code bases. They'll be too complex before you know it. And we all do this, right? I'll show you some phrases like, listen, we might need this in the future. Have you said that? Yes, you have, right? We'll build it more generic, stuff like that. Eventually, we'll need this. If I write my code more generic now, we will benefit from it later. Yeah, sure. Or what if we want to replace this database by another at some point in time? I've heard this argument, especially from people in the Microsoft communities. I don't know why, but they do that all the time, right? As an excuse to write too complex code. Because yes, you know what? We now have a MySQL database, and eventually we'll replace it by a Postgres database. Nobody does that, by the way. I've seen so many projects in my lifetime, and it rarely happens. It does happen when you move to a different paradigm of database, like from a relational database to a document database, for instance, or to a graph database. That is a big change, right? But from one relational database to another, what's the point? They're all free these days, right? Except for Oracle and SQL Server. So nobody, well, anyway. So this is the point, right? Whenever somebody in your team says something like this, or you do it yourself, like might, or in the future, or eventually, or later, or what if, or at some point in time, you need to learn to recognize these little pointers in people saying, right? And whenever you recognize like this, you say, don't do this. Don't go that way, because we are running into premature optimization. And we all do this, right? I've seen so many abstraction layers in architectures that you have no idea what happens, right? The worst I saw was a bank in the Netherlands. They had 19 layers in their architecture, in their software architecture. They couldn't produce a single line of functional code if they even wanted to, because they always had these 19 abstract layers of stuff in there, right? So we create a lot of unnecessary complexity. So don't do that. And there's a good reason for this, is we are still a scarce good, right? We as developers have always more to do than there's time. Essentially to this is that you can only spend your time once. So you need to spend it on the stuff that you really, really read now. Not in 2 years' time. Not when you eventually in 5 years' time might replace the database, which nobody does. Don't do it. Spend your time on the stuff that you need to solve now. Because that's the only way forward. It takes small steps, right? So solve the challenge you have now. Not like, oh yes, we will need scalability, so let's solve scalability now. Why we only have like 2 microservices and a stupid small web interface, right? You don't have that problem right now. I did the very first microservices project in the Netherlands in 2014, 2015. The first thing we wrote was an account service to be able to log in. We tried it out, single instance, running on a JBoss instance. That was it, no scaling, whatever. We could log in 68,000 times per minute. And I was like, and people were like, oh yeah, now we can scale it up. And I said, why would we scale it up? We're not going to log in 68,000 times per minute. Who does that, right? We're not Alibaba. We're a stupid insurance company in the Netherlands. We don't even have like 68,000 customers. Well, we did, by the way. But so don't solve the problems you don't have now, because that doesn't matter, because you can solve them later. And when you can solve them later, it means you have more knowledge about the thing as well. Or new technologies might have arrived that you want to implement that you don't know about now. These are the unknowns again. And it gets worse, because there's always Hofstadter's law, right? Hofstadter's law says it always takes longer than you expect. So tell this to your managers, right? Even when you take into account Hofstadter's law. Think about this one. Take this to your manager, right? And this is an explanation for why we can do stuff. So here's the thing that I taught all the teams that I've worked with over the past, say, 15 years, is ask yourself this question. And this is the most important question that teams can ask themselves. This is, do we really need this now? Or to make it even stronger, do we really need this now? Right? If you don't really need this now, do not build it. And I catch myself doing this all the time. It's everybody, we all do this, because we're sort of like drawn to that complexity, right? So all the time, my teams talk back to me, especially this guy, Nafal. He always comes back to me, Sander, why are you building this? Do we really need this now? And I'm like, oh shit, I've done it again, right? So okay, let's remove it. Just remove the code, right? There you go. So you need to design for replaceability, eventually, right? This is another thing that the don't repeat yourself principle doesn't always work. It's not always true. It's true most of the time, but nothing is true all the time, right? Nothing in this industry is. The only thing that I would say is really, really true is these beautiful rice fields that we have here, is that simplicity is the most important. Because code is not a product. Code is actually cost. So think about it. This is probably very different than how you look into code now. It is not the amounts of lines of code that we can produce. It's the amount of lines that we don't produce, right? Because every line that you write, it needs to be written, it needs to be compiled, it needs to be tested. You need to write unit tests to it, you need to put it through the pipeline. It takes time, you need to maintain it. So all the code that you don't write is better. And I don't mean to say start using low-code tools or no-code tools. Could be a solution, depends on your domain, but it not necessarily is. Right? That means that if you look into code like this, and this is already not very complex code. This is code from one of my team members. It's a set of unit tests in Jest. So this is basically JavaScript or actually TypeScript. And I was looking into this code, and I'm like, it could be simpler, right? And I spent a little bit of time, like an hour or so, to make it simpler. So I changed it into this. It took me about an hour, right? And this is far more readable because, first of all, it's shorter and it has less code. And if it has less code, it's easier to read, usually. You can write really intriguing code, but don't do it. Write simple code. And this, to me, depending on whether you not like JavaScript, but this is simpler code than the one I had here, which means it's easier to maintain. So in the long run, this is much better code. So keep your code simple all the time, because the easiest code to maintain is the code you didn't write. Keep that in mind, right? Because this is really important. It means that I sort of went down on the graph and I got back to writing really simple code. So this is some of my own code, actually, from one of our microservices. It is single-line functions. Now, I'm not saying you all need to step over to single-line functions. I did that, actually, and I did that after years of struggling. And my code got shorter and shorter, and my functions got shorter and shorter, until most of the functions are actually single-line functions. And that is a big change to what I was doing before. And it went down over time, right? This took me about a decade to get to this level, right? These are all single-line functions. Like, okay, what do you need? I need to get all the shops out, so go to the use case, get all shops out. That's it, right? So that's the whole point. I also started changing the way I write my code. Is instead of writing the function first, and in the end of the function, figure out what I need to return, I started doing it differently. I started to write every function I write, or every class that I design, starting with the return, right? This is literally the first word I type in my function, is return. And it makes me think very differently about the code. It makes me think about, what is it I actually want this function to return, right? I'm designing in my head the return value of this particular function. And from there, I start writing the code. What you will see if you do this is that your code comes out in reverse order. And that reverse order is a very interesting thing to do. So I would give you advice is a big word, but you should try this out one time and see what happens if you do this, right? Start by saying, okay, this is my signature. I need to return a promise of JSON. Okay, where do I get it from, right? So write down return. So, okay, so where do I get it? Okay, get it from the API. I need to do a get. Then I need to do some stuff on it, and then it returns. So it's a reverse way of thinking about how to write code. And then when it comes to naming things, I made a 90-degree turn on, like for instance, how it works in Java. Have you done Java? So in Java you have things like this, right? This is a class called the abstract annotation config dispatcher servlet initializer. What is that? Well, it's pretty clear what it is. So it's really concise naming, but it's really long, right? So these days with our modern IDEs, whether you use VS Code or WebStorm or IntelliJ or whatever, PyCharm or whatever tool you're using, they can do this for you, right? If you hover over a piece of code, it will actually show you what the type is of the object that you're using, right? You don't have to write that in the name of it, right? We're done with writing function names there could be a class that has a name like get abstract annotation config dispatcher servlet initializer, right? Don't do that, right? It doesn't make sense, right? You can also call that function get initializer. It's equally good because it's still very concise, because the class that this function is in is very likely already to have a name that is designed to figure out that it has to do with this initializer, right? So you can actually name things very differently if you start doing this. Like this is already a long name, right? This is the service request type repo. That's basically because this thing is called the service request type. I cannot do anything about it. But what I can do is look into the naming of my stuff. And normally I started out when I was writing code like 20 years ago. I was saying, okay, this variable here is probably called order repo because it is an order repo. That doesn't really matter. We know it's an order repo because it says here. And usually my code is so short that it doesn't really matter. I can always see what it was. And then my IDE will help too, by the way. So I can just call it orders. Why do I call it orders? It's a repository that gets orders, which means that if I start using it, I can actually write code like this, right? It says return this.orders by order item ID. I immediately know what it does. I don't have to type get in front of it because I know it. It's a by. So and I can say orders instead of order repo.something. This makes much more sense because it's highly more readable. So you need to think about how to name stuff all the time, and it gets shorter and shorter, right? So you need to try this out. So another thing that I'm trying to learn the teams I work with is never ever leave commented code out there in your code bases. You know why? Because it's fucking confusing. If I open this code and I look like it and I'm like, ooh, why did we comment this thing out? Shouldn't it be uncommented? Does it still need to work? Why are we remembering this thing? And 2 weeks down the road, you don't know anymore, right? This is remove it. There's no need for to keep it here because it's in your repository anyway, right? We all use version control, so you can always find it back if you actually need it. But the code, once you comment it out, throw it away. It'll clean up your code tremendously, right? And also, last thing about this topic is the most secure code is the code you don't write, right? Every line of code that you write is a possible way of hacking into your code, right? All the code you don't write is not. So that makes it really simple. So we need to talk about architecture a little bit, right? So this is one of the most beautiful pieces of architecture I've seen in my life. This is the Colosseum in Rome. These are actually the underground catacombs that, well, people used to wander around in. This is an amazing building. It still stands there after 2,000 years. It was officially in use for about 500. Why? Well, because they were able to adapt it all the time. At some point in time, they put this wooden floor in and they put water in. So you think, oh, they have a nice swimming pool, they could organize swimming contests. No, they did. They organized naval battles inside of the Colosseum, right? So this is a highly adaptive building. Of course, it's not functional anymore now. It's a tourist attraction now. Beautiful building. But the thing is this, right? If you look into what the famous programmer Charles Darwin says, he has a beard, right? Remember? He says, it's not the stronger of the architectures to survive, nor the most complex that survive. It's the one that are most adaptable. That's the thing. You need to be adaptable without putting all the complexity in, right? Being adaptable does not mean make it more complex, add more layers of abstraction. It means do the minimum thing that keeps you going. And I'll show you a bit how you can do this. So Neil again says, an evolutionary architecture, which is where you should be going probably, it supports continual and incremental change as a first principle along multiple dimensions. He basically says you need to create an architecture that allows you to move on without even possibly breaking the rules of the guidelines of your architecture. Can you do this? Yes. I'll show you an example of that. And it all starts with naming the things in the right way. So you need to figure out what are the patterns, the layers that you tend to use in your architecture. I'll show you mine. That doesn't mean I advise you to use mine. I'm advising to think about how you put up your architecture. And I'll show you why we do this and also the rationale behind it. So in 2003, one of my books was published, and it was a book about UML. You're all young, so you have no idea what UML is these days, I suppose, but it's a modeling technique, right? Or it's a set of modeling techniques, basically. So in this book, I sort of described a small architecture, and that was 20 years ago. But the funny thing is, I'm still using it. The programming paradigms have changed. I moved to functional programming. There is a lot of change in the background, in the infrastructure, everything, right? But actually, these principles and patterns are still alive. So it starts by saying, I have a domain. The domain is the heart of what I do. So in there's like entities, value objects, enumeration, stuff like that describe your domain. Around it sit something that we call repositories. Those are the codes, the samples that I showed you earlier. A repository is there to give you instances of entities or maybe to store them somewhere. This is what repositories do. It's a pattern from the domain-driven design book. It's a really strong pattern. It's really, really useful. So the next step is there is some process around. Not everybody does that. We use use cases to sort of say this is the process that we're trying to implement. So the process code goes into the use cases. They're also good for like authorization and stuff. We use it for some complicated stuff. So when this thing is a microservice, it has a service interface. So it has an API. That API resides in resource classes. So every endpoint lands at a specific resource class and it passes it on to the next step. So that's its sole responsibility. Now, and in the end, you need to go out. So you need to go into a database, into some other services, in something that sits outside of your field, wherever you are. This very simple architecture has survived over 25 years of coding. Much to my surprise, actually, because I started doing this in Java and I started doing this in C# and all sorts of different languages. And actually found a code base, one of mine from 2014 recently, that actually, it has these layers. It's probably hard to read, but it has the 4 layers that I described in this architecture. And I'll show you some different implementations of repositories. So here's one in C#. This comes from 2008. This is my own code in 2008. It is essentially doing the same thing, just that the code is written differently. Then I started doing it in Java. So here's one. It has more code, right? Longer code. It's Java. It's highly verbose, right? So, and here's one in Python actually that I got from one of the guys on my team. And this is basically an abstraction of a repository, by the way. But and here's one in TypeScript. It's shorter. Actually, shortened down everything, right? It's now called repo instead of repository. Still the same thing. It's the same pattern. And I've been using that pattern for years and years in different implementations all the way. So again, I'm not saying use mine. I'm saying use one. Right? Figure out your architecture because it's relevant, especially if you have like us. We currently have like 150 small repositories. Every one of our microservices, every one of our workers, every one of our micro applications sit in one of these repositories. They all have the same structure. So that means if anybody on my team dives into any one of these 150 code bases, they immediately know what it's about. And that is a really strong thing, right? By the way, if you want to know more about this architecture, this is a screenshot I took from the GitHub repo that the open source framework sits in. It sort of describes that architecture too. So then there's the last thing about architecture is that basically what I think you should do all the time is wait until the last responsible moment to make decisions. That sounds really counterintuitive, right? Because most people are used to like saying, okay, we eventually need a database, so we sort of need to get that database in order now. We need to know where the database is from. And we need to sort it out now. And I'm saying, no, sort it out later. Because at some point in time, when the first line of code you write that you need to do this implementation, that is the point where you need to decide stuff, right? Not before that. So, I need to move on a little bit, so I'm going to put some stuff in the code that in the talk that I will do this afternoon. But I want to touch on another interesting topic, which is testing. So, we're nearly there, by the way. So, this is about testing. So, my question to you is, do you guys write unit tests? Yeah. I see two little nods, right? If you're not writing unit tests, start doing that tomorrow. Tomorrow's Monday, right? Yeah, so start doing it tomorrow, right? So I'll explain to you why. And I'll also explain to you why writing unit tests is not even enough. You need to do more. So here's the thing. Michael Feathers, a very nice guy, he says, well, a test is not a unit test if it either talks to the database, so it shouldn't write, it should isolate, or communicates across the network, touches the file system, if it cannot run in parallel with some other tests. This is an important one, right? Because if you have tons of unit tests, they take forever to run, which means if you can run them in parallel, it's much better. So you need to make sure that every one of your tests can run independent of the other ones. Also, if you have to do all sorts of configurations to make it run, it's not right. So unit tests are really valid because what unit tests do, and the yellow is not really good readable here, I suppose, is that they show you which of your code works and which doesn't, right? This one clearly fails, which means I've done something wrong, right? And the nice thing is you have these unit tests on your pipelines. I'll talk a little bit about pipelines in the afternoon. But so this is SonarCube. It has run all my unit tests. It considers my unit tests okay because I have 95% code coverage, which means I'm pretty sure that my tests have covered all this code. Now, what code bases? And for me, this was an epiphany. When I first started writing unit tests last week, no, that's not true. It's like maybe 10 to 15 years ago, I suppose. And over the time, I learned something really important from writing unit tests, is that having these tests gives you immediate feedback, right? You have the code, you have the test, you run the test. If they fail, you need to change the code. Or eventually you might change the test, right? So it gives you a lot of confidence about the code that you're writing. And I came to the realization that what we tend to do is we tend to not debug our code anymore. I see less and less people on my team, including myself, actually debugging our code. What we do is if it fails, we'll just add another test to see why it fails. Instead of using the stupid debugger. I probably use the debugger like twice per month, which is really little, I suppose, but it comes from the fact that we have these unit tests for basically everything. It even allows me, it gives me so much confidence about what I'm doing that if I'm changing the implementation of stuff that's in our frameworks, like in the open source frameworks that we use, there's so many unit tests on that code that I can change it with confidence, right? This is from our list class, or our page list class in the open source framework, and it has an implementation like this, and I looked at it and I'm like, I can do better, right? I can make it more cleaner, more readable. But this is a class that is used everywhere. So if I change this and it breaks, I break other people's code, even the code of people I don't know. This is one of the nice consequences of writing open source code, right? So basically, I wanted to change the implementation to something like this. It's a little bit nicer, not much, but it's much more secure because I'm putting this in this operator, which basically means that it will run that within a try-catch block. So that means this is a change in one of the base classes. But because I have so many unit tests on that, I actually dare to make this change. And this is a big thing, right? Quite often when you run into complex code bases, you dare not to change the code that's in there anymore because you have no idea what will break if you do that. If you are at that point, you need to start introducing tests. And you need to start writing the unit tests now. And you need to do that all the time, by the way. But one warning, writing unit tests with existing code or with the code that you're writing after you've written the code is rather passive. And there's something you can make much more use of than just saying, oh, I'm going to write some code. So I tried to evolve it with some of the people on my team. And these are quotes from one of the developers on my team. And she said, well, yes, I just wrote all the code. This is how she started, right? When we just got her on the team, she said, yeah, I just wrote all the code. Now the business needs to test the code. I'm like, yeah, okay. It's a step, right? At least there's somebody testing the code. But what happens, right? So you write the code. You go to the business who are one floor down from us. They might be there, they might not be, right? And you go there, let's say they're there. And you say, well, can you test this code? And then they look in their agenda and say, I can do this on Friday when it's Monday, right? So they can do this somewhere next week. So you have a delay, a feedback loop of around 4 days. Then they test it, and they come back with a tiny remark. And you fix the remark, and you go back to them and say, can you test it again? And they're like, yeah, I can do it on Friday again. So there goes another week, right? And this is a very slow and tedious process. So your feedback loop on doing this is extremely long. And that's extremely expensive, right? Because in all that time, you just need to wait until it's there. So if you can test most of the stuff yourself before having to go to the business, it's much better. So this is what I explained to her. Then she came back to me after 2 months and she said, well, you're right, I did improve. She said, so I just wrote all the code for this particular feature, and now I'm going to write the tests. That means she struggled at writing the code, making sure it works, she thinks it works, and then she'll start testing. This is, again, has a very long feedback loop. It's shorter than the previous one, but it still might be 1 day. So you write all the code for a specific feature, and depending on how big that feature is, it can take a few days, right? And then you start testing. And then you start again with redoing the code and refactoring the code, and then you start testing it again. Again, this is a much longer loop than it actually needs to be. And it costs a lot of time. So then comes the next step. And then I said, well, what if you continuously refactor and code your test, right? And then try to work on it. And then she said, well, yes, I refactored the code into several small functions. So I said, well, write smaller code so you can easier test it. And then she said, well, they're much easier to test now. So that was good. And she said, okay, and now I only need to rewrite the test. She still did it afterwards. And the thing is, although she started writing unit tests instead of going to the business to get it tested, it is still very passive because it's still writing all your code first and all the struggle you have with writing your code before you start writing the tests. So you should do better. You should consider testing to be design. And that is a very different concept, right? So, or you could, right? When I say I should, I mean you could. It's not mandatory, but it helps. So here's the thing. Here's Gerald Weinberg. That's the guy from the pinball machine, right? He looks like a guy who plays pinball. He said, design is the progressive elimination of ambiguity. That's a nice definition, right? So he says basically, when you're designing in your head, you remove more and more of the complexity that necessarily sits in your code. And you end up with less code, which is really, really good, right? And if you listen to Dave Farley, nice guy. Last time I saw him, we were on a boat somewhere. He says basically this. He said, you need to start applying rational thinking to this, or scientifically rational thinking. He says, starts with assuming that we are wrong, right? We all tend to write our code, and I have a guy on my team, a really good developer. Every time he writes code, he says, well, this is going to work. And I say to him, how do you know? He says, well, I've been programming for 30 years. I know. And then quite often it doesn't work, right? You know that. That happens. It happens with my code all the time, right? So here's the thing. He says, yes. And then he started saying, no, I think it should work. And then I say, how do you know? And he says, well, 30 years of programming, right? And so, not enough. So go beyond that, right? Instead of thinking that your code will work, assume that it doesn't. And that's an entirely different way of looking at it. It's pretty much the same turnaround as starting with the return statement. These two go along really well, by the way. So you need to test the ideas that you have by assuming that it doesn't work. So here's what you do. I'll give you a really quick and simple example. And I'm using TypeScript because I love TypeScript, but also because it's fairly easy to read, right? So here's the function that I want to write. So I'm starting to think. This is an identity class. Identity, we can ask an identity if you're logged in, whether you're allowed to do something or not. So I created a function called isAllowed. And the first implementation that I will be writing is some that just fails, right? Because, well, I'm assuming it goes wrong. Then I write a test. Now, if I look into this test, the only thing I need to do is figure out, okay, I'm creating a new identity, and I'm checking the isAllowed function, and it should be false. It is, right? Because it returns false. It doesn't do anything. But now I have a test, which means I can actually check whether this is true. It should be true, right? And then the next step is to think about what the actual signature for my function would be. The actual signature for it to be, I give it a set of scopes, and I want to know whether this identity is allowed to, has one of these scopes, basically. That's the point. I still don't do anything, but I just add to the signature. Then I can write a whole set of unit tests. Basically trying it out with different sets of scopes, or maybe with no scope in it, or with an empty object in it, or whatever you can try. And there's all sorts of falseness that you can try out. Usually it's a bit like I create all this false tests, like, oh, if I don't pass in any scopes, it should be false, right? So I haven't any scopes to check, so it should be false. Then there's one that I'm going to test with, oh, I'm quite sure it doesn't have support scope, so I'm going to test that, so I'm going to make it false, because this identity doesn't have any scopes. If I create one with that has scopes, like it has the basic and the admin scope, and then I'm going to check with, well, if it has, it should be falsy if I ask it to have support scope, because it's not in there, right? All these things should be false. And when you've gone through all the cases that could be false, so you're testing whether your code actually is false, then you write the right one. So this is the one that I expect to be true, right? So this one with the basic scope is in there, so it should be true. It's not, by the way, because I didn't implement it, right? So I'm going to run these tests. And they all succeed, except for the last one, of course, because I didn't implement anything. And at that point in time, you can start implementing the code. So I'm now writing the code. This is, by the way, a very simple function. I'm just creating a list out of the scopes, and I'm asking if it overlaps with the ones that we have. Does that work? Well, probably. So I'm running the tests again, and if I run the test, they're now all green. Which means I'm actually using to write the tests to design my code. And that is a very big step from writing unit tests, because instead of doing it passively, you're now doing it actively, right? And that is an extremely big step. So here's the thing. Test code is often ignored. Even if you write test code, people leave it behind saying, this is only test code, right? My advice is, don't do that. Consider test code to be it has to be of the same quality as you write your other stuff, because otherwise you get all sorts of really complex code that after a while you cannot read your tests anymore. And the tests are there for the long run, right? I don't only want to know whether it works now, I want to know whether it still works a year from now, or 2 years from now, literally 2 years from now, or 5 years from now. We're maintaining this open source project. It runs about 1,500 unit tests. They all need to be green when I change even one letter of code, right? And they need to do that all the time. So the code needs to be maintainable. So instead of doing this, well, this again was code from one of my colleagues, I rewrote it to do this. It's still simple, right? You need to write the simple code. So 2 more small topics to go, but these are just maybe afterthoughts. One of these afterthoughts is one that I really, really love. Do you guys use pull requests? If you run an enterprise company, you probably say yes, right? Does that mean there's somebody reviewing your code? Okay. think about what I said about if somebody writes the code and then goes to the business to get it tested, that it's a very long feedback loop. What about pull requests? What about code reviews? How long does it take before your code comes back? Usually, right? A day? 2 days? Longer? A week? It could be, right? It could be that the person you're asking to review it is not there. He might be on holiday in the Philippines or whatever they do, right? So they might not answer you immediately. It takes a while. That means they're looking at your code maybe some days later, maybe a week later, maybe 1 day later. That still is a delay that you could have avoided. That is why we start pushing towards trunk-based development. In trunk-based development, the principle is actually simple. You don't branch. And are you looking at me, what? I cannot create branches? No. It doesn't mean you can't, it means you shouldn't, right? I advise against branching all the time. You know why? Because branches tend to lie around forever, right? If you're working on a problem and you run into that wall in the desert and you're thinking, I have no idea how to do this. You're letting your branch lie. It lies there for 3 days, 4 days, maybe longer, right? It goes back over the weekend. Somebody else does something on the trunk in the meantime. And at some point in time, you need to merge back. Merging back code bases that have been, or branches that have been out there longer, the longer you wait, the more expensive it becomes in merging it back. What if you wouldn't do this? And then you say, yeah, but we need the pull requests and we need the reviews. No, you don't. You need to write code collaboratively. That is a very different concept. Because instead of doing reviews afterwards, like after a few days or after a week, you can also write it together with somebody else. And your manager might say, no, that's too expensive. I cannot have 2 developers writing on the same code base. That is short-sighted. So tell to your manager that I said it's short-sighted, right? So let them, give me the blame, right? So that's good. So the thing is, every small change I make on a code base, I check it in immediately, of course, after running all the unit tests. Then what happens is, it gets checked in, it goes through the pipeline. If all the tests at all the levels run green, so my unit test, my static code analysis, my linter, my compiler basically, then it gets built and it's deployed, and then I run all the API tests, and then it goes further, further, further. If all the tests are green, it's good. It also means that if I check in my code multiple times per day, directly to the trunk, other people will already have my change, right? That has a bit of disadvantage, I know, right? You're all thinking, yeah, but doesn't that give trust to the other people because they have to use your new code and you don't know if it works? That is true, but I have all these unit tests in place, so I do know that it works because every time I check it in, I run all 1,500 unit tests and I'm pretty much convinced that it will work. So if you move towards having high levels of code coverage on your unit test and having everything green, it gives you the confidence to do stuff like this. And if you can do trunk-based development, you're way better off than if you have to wait for peer reviews or code reviews, pull requests and all this other stuff, right? So make it short and check in all the time. That is a tip I can give you too. Last thing, right, if I'm correctly. So the last thing is, it's a bit about traveling again. This is my mom, the one on the left side, not to be confused, right? So this is my mom. I took her out to dinner. I do that all the time. I got back from a trip, and she said, and I showed her the pictures. I was in Italy, and I showed her the pictures, and she said, wow, why did your dad and I never go to Italy? And I'm like, well, I can tell you, because you guys have been going to the same campsite in the south of France, beautiful campsite, by the way, in the south of France for 25 years. You always come back to the same place. That's why you've never been to Italy. They were in Italy, by the way, but that was when they were young. But the last 25 years, they spend at the same place. And every time I go somewhere, she's like, why did I never go there? Well, you went to that campsite. Is that wrong? No, it's right, because it's her choice. It is also the way she has set up her life, right? It's a choice. She wanted to go to the same comfortable environment. A lot of the developers out there are like this, and that's really good because we need tons of those developers, right? If you go into the COBOL community, that's usually people twice your age, by the way, if they haven't already retired, but they tend to work on the same code base for years and years. I've worked with COBOL developers who spend 30 years of their life working on the same code base. Why? Because they love doing that. I have Java developers on my teams who do the same. And it's basically an attitude that you have. Not everybody needs to like to change all the time, right? I do. I like inventing new stuff. I like having these epiphanies and doing these experiments and change stuff all the time. My team sometimes complains and says, why did you need to change this? And I'm like, because I could. But a lot of people are not like this. So you have to think about what fits your life best, right? And if you are the person who wants to change stuff, who wants to get your teams and your teammates and yourself mostly, get them better, and make them run faster maybe, or make them work better, or collaborate more, you need to experiment. You need to go through these loopholes and see that you can actually grow really rapidly, right? But it doesn't have to be that way. My mom is not like this. I am, right? I love the change, right? This is me. I try to drive a tuk-tuk. Have you ever driven a tuk-tuk? It's horrible. I rented one when I was in Sri Lanka, and I was like, oh, I can go cross-country with it. I can actually drive 200 kilometers on a day with this thing through the roads in Sri Lanka because they go like 40, 50 kilometers per hour. So I can easily do 200 kilometers. I didn't take into account the traffic that I would encounter, right? It's pretty much the same as here, right? You have the tricycles on the road everywhere. If you drive a car, you cannot pass because, well, there's a curb in the road and all that stuff. You don't know. These are the unknowns, right? And I love encountering the unknowns on that's just like nature and storms and whatever, but I like doing that change. So there's either you have this nice idea of comfortable repetitiveness, which is really great because we need lots of people like this. But if you really want to ignite the change in your team, in your company, and basically in your own head, I actually tried this out once in the parking lot. It works, by the way. So if you're the first one to park it the other way, everybody will do it. It's pretty cool, actually. It's a nice experiment. Try it out sometimes, right? So, but if you are really wanting to do this change and you want to change for the better, there's only one way to do it. There's only one person who can ignite the change in yourself, in your teams, in your company. And you know who that is, right? It's you. You can ignite this change. So, last advice is, don't be afraid to ask stupid questions. I ask stupid questions all the time. And people allow me to do that because it makes them think, right? It makes them think that you're actually really wise if you ask stupid questions. Because to them, they sound like really deep questions. But you can just ask stupid stuff like, what's the unit of work on a timeout in an access provider? I don't know. I can look it up. ChatGPT knows, by the way. But it actually does. So here's the thing. Last thing is, you can never stop learning if you want to ignite that change. If you want to make your life better, right? If you want to become a super programmer writing really tiny bits of code and having them all unit tested and having them go to the pipeline immediately, you can never stop learning. Last thing is, you can never forget to have fun. Oh, one last more thing. Take your mom out to dinner more often, right? Before you know it, you can't do it anymore. So that's me for this morning. I'll talk a bit more about teams and collaborations and pipelines and stuff in this afternoon. I still need to come up with the deck, so I have lots of material, by the way, but if you have any ideas, just come up to me and I'll put them in. Thank you very much for indulging me over time.
So I think now is the time for Q&A. So guys, if you have questions, please approach the microphone there and line up so that we can ask the speaker to answer your questions.
The question that I would like to ask is, one of the things that you said in this talk is that it's virtually impossible to know how long the code will finish, right? However, on the business side of things, they really want to know how long it takes because code comes at a cost. Yep. So how do you find the middle ground of respecting your developers' time and respecting your business people's desires to have estimates or cost approximations?
Yes, that is, this is probably one of the hardest subjects in this industry. Next to naming things and cache invalidation. But so this is really hard. You actually said the right words. The thing is to find the middle ground, right? So we as developers, when we're doing new stuff, you need to figure out how new is it. And I've left out some of the slides that I usually have in this talk, but that's when I have more time. So I'm going to use them this afternoon. There's this model called Cynefin. And Cynefin is a model that describes whether stuff can be repeatable, so predictable, so estimatable, or stuff that is on the, let's say, the unknown side. So you need to figure out when you are in the unknown zone or when you are in the known unknown or known zone. So when you're in the latter zones, it's easier to estimate. So the easiest way to find the middle ground, but it's still extremely hard, is to not try to estimate every single little work item, right? So if you guys are estimating at story level, if you guys are estimating at task level, which is even lower, stop doing that, right? Because it doesn't make sense. It doesn't have added value. What you could do, if you would use the same metaphor, is estimate at one level above that, like epic level. Like, to give you an example, over the last couple of weeks, we've been working on a new, well, it's called the Hunt page. Hunt is a specific type of sale that we have at this company, and we redesigned that page altogether, which is quite a bit of work, actually. So it took us like 3 to 4 weeks. Before we started, we didn't know, but that was the level at which we started to estimate. So we said to the business, we're going to build the new Hunt page. It needs to be ready before the next Hunt, which was actually 2 days ago, and we were done, by the way, and we think it will take about 3 weeks. So, but if you go into lower levels of estimation, where people think you get a higher accuracy, it's actually not true. Because going into lower levels means you need to know much more specific about the individual tasks and stories and whatever you might have, which you usually don't know. So you need to go up, and you need to go to the ballpark figures. And it's usually okay if you can make understand that you don't know everything, which is, for sometimes it's hard to admit, right? I don't know, there's lots of stuff I don't know, actually. So try estimating at higher levels. So give them a ballpark figure and figure out what's the middle ground in there. Can they live with the fact that I'm saying, okay, it's probably taking 3 to 4 weeks, or maybe better, taking 2 months, maybe 3. So if they're okay with that and not the exact deadlines, because deadlines are even harder than estimation, then you can be okay. But it's an extremely hard topic.
Okay, thank you. One last question. You've introduced to us trunk-based development,
Yes.
right? The issue that I find with that, based from your introduction, is while collaborating with teams, I think it is really easy for people to just change things and have conflicts upon their own styles of code from one coder to another. So the question that I have is, given that if we're going to pursue trunk-based development, how are we going to ensure that the developers will not just change one thing and break the whole branch?
Well, yes, that's the right answer, right? Write the tests. You cannot check in the code unless you have it all tested. So if I change something now, let's say I would open up my IDE, change some code, check it in. I only check it in if I've run all the unit tests and I'm pretty sure that all the code I wrote, which are, by the way, usually very tiny changes, that I can actually get them through the unit test. And only then I can check in the code. So the chances that I break the code, there's still a chance that I break the code. It happens, by the way, but that's why you are a team, right? That means that you can solve it immediately. Still, if you do that, still if it would break on the pipeline or I break somebody else's code, we see it immediately because the pipeline fails, right? That means that the feedback loop is still extremely short. It's a matter of like, the pipeline runs, puff, 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 puff. 2 minutes later, I have the feedback. That is still much shorter than I would have to give it to somebody else with a pull request to actually go out and do the code review and come back to me 3 days later, at which point in time I already don't know anymore which code I wrote, right? So it's always, you need to have the tests in order to do this. So you cannot do trunk-based development unless you got everything unit tested. And the whole team has the discipline to do that.
Okay, I see. Thank you, Paul.
I have a question about trunk-based development and CI/CD.
Yeah.
So trunk-based development, I think it's a good idea, and I'm trying to like implement it in our team. But it's, I guess like the trouble that we're having is, should we be deploying to production every time we deploy to the trunk? And I guess like, you know, we have tests and we have like hundreds of tests.
Yeah.
But I wouldn't say that I'm like 100% confident that like if the tests pass, we can deploy this to production and not cause an incident. So
Yeah.
I was wondering like what your approach is to that sort of thing.
Well, there's no universal truth, right? There is no silver bullet in this. So whether you go to production or not automatically, which is called continuous deployment, right, over continuous delivery. And continuous deployment is a really nice thing to do if you can do it, right? Not everybody has the code base, the environment, the company, the team maybe to implement this. We do, by the way. So every change in the code I make goes into production automatically. I would actually, if I would have the time, I could actually live show it. Maybe I can do that this afternoon. So it literally goes into production when it passes all the phases in my pipeline. So if you go into this direction, you need to make sure that your pipeline has all the right steps implemented to make sure that you can do this. The question then you need to ask is, should I really want this? It's not about being able to, because you're able to, right? But it's about, do you really want this? Not everybody is up to this yet. It does give an enormous boost to how you write code. It changes the perspective immediately, because as soon as the business realizes that you can do this, that you can change the stuff that's in production within like 3 minutes, they're going to ask really different questions than they do now, right? Now they come up to you with a requirement that says, oh, we need to build this feature, and this, and this, and this, and this, and this. It all needs to be in there, because they know from experience that if they don't ask it up front, they'll never get it, right? And if you move towards trunk-based development and having stuff going to production, so continuous deployment all the time, they change the way that they ask questions. They're going to say, I want the minimal version of this function now, of this feature now, and when it's in production, I'm going to A/B test to see which additional stuff that we want to add to it. So the whole perception of how you write code and how you integrate with the business will change if you do this. For the better usually, but that still doesn't mean you have to, right? It's not mandatory, it's an option. So if your company is not ready to go there, you don't have to do this, right? You can do it in a continuous delivery mode and take the last step manual. But it takes time, right? And it's the question of, do you want that?
Right. Okay, thank you so much.
You're welcome.